Hello everyone, welcome to the video lecture series of cryptography and network security. I am your instructor Dr. Ramesh Prajapati and today I am going to discuss the RSA algorithm. So let's see the agenda of this video lecture. The first RSA algorithm. So let's start the RSA algorithm. So RSA algorithm, this is for the asymmetric encryption, or we can say that the public key algorithm. Why it is called the public key or asymmetric algorithm? In a symmetric encryption, we are using one key for encryption and the decryption. But there is some drawback. To overcome that drawback, we are using the asymmetric encryption. That means the drawback of symmetric encryption is if the attacker or a cryptanalyst know key, then he or she will find the message. So to overcome this problem, we are using the asymmetric encryption. So in asymmetric encryption, we are use the two key for we are using the two key for encryption and the decryption. That means the two keys are public key and the private key. Two keys are public key. Two keys are, one is a public key, second is a private key. Public key is known by every user in the network, and the private key is not shareable. And if you want, and if two parties want to communicate with each other, so the first of all, both the user can share their public key to each other. So now let's see how the RSA algorithm is work. First letter of their surname, Rivest, Samir, and Edelman and Edelman. Now let's see. The RSA is a block cipher in which the plain text and the cipher text are represented as an integer between 0 and n minus 1 for some value of n. Now here large message can be broken up into a number of blocks. Again the same thing, if your plain text is very large, so you have to divide it, the large message, into a number of blocks. Now each block would be represented by an integer. It should be an integer. Now let's take, there are three steps to encrypt and decrypt the message. So let's see the first step. First of all, there are two parties want to communicate with each other. So the first, it generate the public key and the private key. Each and every user have to generate the public key and the private key. Now in the second step, encrypt the message using the public key. Now in the third step, decrypt the message using the private key. So let's see the first step, how to generate the public key and the private key. Assume that there are two users, Alice and Bob. So the first, Alice want to generate the public key and the private key. So let's see how to generate the public key and the private key. So now the first step, we are considering the large prime number and it representing in a P and Q. Now the next, to calculate the Euclidean now to calculate the modulus of RSA algorithm and it representing of n, and n equal to P multiply Q, you will get the calculate modulus n. Now the third step, calculate the Euler's tuition function, right? And we have seen in the previous session, we have seen how to calculate the Euler's tuition function. So there is one formula, phi of n equal to P minus 1 multiply Q minus 1. Now the next step, select the E. E means encryption. E such that E is a relative prime to phi of n and E should be between 1 and phi of n. Now what do we mean by relative prime, right? Or we can say that co-prime. So here the two numbers are relative prime, it means they have no common factor other than 1, or we can find the GCD of phi of n, E equal to 1. So now Now the next step, determine the D, it means determine the decryption key D such that D multiply E equal to 1 mod phi of n. Now here you know the E, based on that E you have to find, you know the E and the phi of n, based on that E and phi of n you will get the D. Now the public key is representing a PU, and in the public key E comma n, we have required the two things in the public key. E is encryption key and second is a n. Now in the private key again we have required representing a PR, and we have required the D comma n, because in the receiver side it decrypt the message, so that's why they have required the private key, and it will be the D of n. Now the second step, encryption and the decryption. How to perform the encryption and the decryption? So there is one formula to encrypt and decrypt. So the formula of encryption using the public key is the plain text is representing M, cipher text C equal to M raised to E mod n. So this is the, with the help of this formula we will calculate the we will encrypt the message, and after applying the encryption it's generating a cipher text. So here C is representing a cipher text, M is representing a plain text, and E is representing the encryption key mod n. Now same for a decryption using the private key. So here the cipher text is representing a C, and the one formula to decrypt the message. So the formula is M equal to C raised to D mod n. M is original message, C cipher text, D decryption key mod n. So now I hope you clear this idea. So these are the steps to generate the public key and private key, encryption and the decryption, perform the encryption and the decryption. Now let's see one example to clear this idea. Okay, how to generate the public key and the private key. So now Alice want to communicate with Bob, so Alice generate the public key and the private key. So now here assume that two large prime number P equal to 3 and a Q equal to 11. You have to assume that the P equal to 3 and the Q equal to 11. You have given P equal to 3 and Q equal to 11. And as in an example also you have given the P and Q. Now calculate the modulus n. So the equation is P multiply Q, so you will get the 33. Now calculate the Euler's quotient function. So you have to find the phi of n. So the equation of phi of n equal to P minus 1 multiply Q minus 1. So here 3 minus 1 multiply Q, 11 minus 1, you will get the 20. Now select the E such that the E is relatively prime to phi of n, and the E should be between the 1 and the phi of n. So now we have several choices, like the number of relative prime is 3, 7, 11, 13, 17, 19. So let's take E equal to 7. Now here we assume that the E equal to 7. So encryption P is equal to 7. Now so this is the, now we have to calculate the decryption key also. So determine the D. So there is one formula to find the D. So D multiply equal to 1 mod phi of n. So now to calculate the D. So here the D is a question mark because we have to find, and E is equal to 7. So 7 equal to 1 mod phi of n equal to 20. So now what to multiply with the 7? What to multiply with 7? So you will get the remainder 1. What to multiply with the 7? So after performing modulo operation, you will get the answer 1. What to multiply with the 7? You will get the remainder 1. So now here we use a 3. 3 multiply 7. It means you will get the 21. So the 21 over 20, you will get the remainder is 1. So now your decryption key is 3. Now our decryption key is 3. So now here the public key PUEN equal with representing the 7 is a public key and is a 33. Now here this is also the equivalent to finding the D, which satisfies the D E equal to 1 plus J multiply phi of n, where J is a integer. And we can rewrite this equation like this: the D equal to 1 plus J multiply phi of n divided by E. So with the help of this equation, you will also find the D. Now the private key is the PR equal to 3 because our D is 3 and the N is 33. So now the first step is over. It means we have generated, it means Alice has generated the public and the private key. Now he want to encrypt the message. So how? Let's see. So the encryption using the public key is, well, there is one formula to encrypt the message: C equal to M raised to E mod N. So here M is input message, you know that, and E is a public key, and N is our module. Now here ciphertext C is representing a ciphertext. So let's see, the PU is 7, 33 and our message is M equal to 14. So how to encrypt the message? How to encrypt the, now Alice want to encrypt the message. So how it encrypt the message? So here you can see the formula is C equal to 14 or M is 14. So here 14 and our E is 7. So 14 raised to 7 mod 33. Now calculate this. How to calculate this? You can see over here. Here you have to divide this 14 raised to 17. So how to divide this? You can see the 14 raised to 1 mod 33 multiply 14 raised to 2 mod 33 multiply 14 raised to 4 mod 33 mod 33. It means that 4 plus 2 plus 1. 14 raised to 4 plus 2 plus 1. You will get the 7. So now you will do calculation like this. Now 14 raised to 1 mod 33, you will get the 14 because 14 raised to 1 14 and 14 mod 33 you will get 14. Now 14 raised to 2 mod 33, so you will get the 31. Then 14 raised to 4 mod 33, you will get the 4. Now to multiply this 3, again you have to perform the mode of 33, so you will get the 1733 mod 33. So you will get C equal to 27. So this is the encryption. Now how to perform the decryption? Now Alice sent this message to the bomb. Now Alice want to decrypt this message. So decryption using the private key. The private key is known only by the bomb because the bomb's private key is known by only bomb, and the private key of Alice is known by only Alice because private key is not sellable. So now formula to decrypt the message. So M equal to C raised to D mod N. So now let's see. As you know that this is the ciphertext, D is a decryption key and N is a modular and M is a plain text message. So now our PR is 3 and 33. Decryption key is 3 and N is 33. Now the ciphertext C equal to 27. We already calculated the C equal to 20. Now M equal to, our equation is M equal to 20 raised to 3 because C is 20 and B is 3. So 20 raised to 3 mod 33. Now again we will do the same calculation. 20 raised to 1 mod 33 multiply 20 raised to 2 mod 33. So 2 plus 1, 20 raised to 2 plus 1, you will get the 3. Now 20 raised to 1, you will get 20. And 20 raised to 2, you will get the 4. So multiply this 2, you will get the 18 mod 33. Now perform the, now you will do the calculation of mode 33, you will get the 14. So now this is the decryption process. So this is all about the RSA algorithm. Now let's take another example. Now this example is this previous example is represented in a graphical relation. So like this, you can see this is my plaintext message 14. Now apply the encryption along this equation. 14 raised to 7 more 33 equal to 20. So our PU encryption key is 7 and the N is 33. Now you will get the ciphertext is 28. Now again apply the receiver side or bomb is apply the decryption along with the private key. So now 20 raised to 3 more 33 equal to 14. So now here PR is 3 and 33 is a N. So this is the example of this. Now let's take another example. Here you have given the N phi of N, find the N phi of N E D for P equal to 11 and Q equal to 5. Here you have given P equal to 11, Q equal to 5, and you to find and you to perform the encryption or decryption, and the message is M equal to 16. So let's see. The first you to calculate the N. So the P multiply Q, you will get the N. So N equal to 55. Now find the phi of N. Phi of N equal to 14. Now finding the E relative prime to 14. So E must be smaller than phi of N is co-prime to phi of N. We will be using the 7. So now here we assume that the E is equal to 7. So here finding the D such that D multiply E equal to 1 mod phi of N. So now we will do the calculation to find the decryption D. Now let's see. So here you can see our PU is 7. That means we assume that E equal to 7 and N equal to 55. Now do the calculation for the D. So here our formula is DE equal to 1 mod of phi of N. Now our E is 7, so D of 7 equal to 1 modular 40. So now we will use an Euclidean algorithm to solve this equation. So here you can see the 40. So we put the 40 on one side of the equation and we find out how many times this 7 goes into 40. So our answer is 5 and the remainder is 5. So the 7 multiplied 5, you will get 35 plus 5, you will get the 40. So now we will do this same process for the remaining value. So now you will get 7 equal to 1 of 5 plus 2. It means this 5 goes, we put the 5 on another side of the equation and find the how many times this 2 goes into 5. So the answer is 2 and the remainder is 1. Now we stop. Now where we stop? We stop at the last non-zero remainder. Here you will get the non-zero remainder. Remainder is 1. So we then use the extended Euclidean algorithm to solve Euclidean algorithm, and it is also called the extended Euclidean algorithm. So let's see how to perform the extended Euclidean algorithm. So first we start with the 1 because that was our first result, right? In the previous result we got 1 equal to 5 minus 2 times 2. From above we know 1 equal to 5 minus 2 times 2, right? So we will use same equation. Now we will substitute the value of 2 over here. So the value of 2 is 1 equal to 5 minus 2 bracket 7 minus 1 of 5. So now 7 of 2 minus 2 of 5. So the 2 of 5 plus 1 you will get 3 of 5. So 3 of 5 minus 2 of 7. So now again substitute the value of 5 over here. So the value of 5 equal to, so here the equation is 1 equal to 3 inside the bracket the value of 5. Substitute the value of 5 is 14 minus 5 of 7 minus 2 of 7 is same. So now the 3 of 14, now 3 of 14 minus 3 multiply 5, so 15, 7 minus 2 of 7. So now you will add this two number 15 of 7 minus 2 of 7, you will get the 17 of 7. So now combine this common value. Here you will get the original value is 40 and the 70. So now here because this is the now minus 17 is a negative number, so we cannot consider the negative number. So we have to convert into the positive number. So now the minus 17 mod of 14, it means we have to add the 14 into 17. So the 14 minus 17, you will get the 23. So the D equal to 23. So now our decryption key is 23. So now we have two values, public key and the private key. Public key is 7,55 and private key is 23,55. Now we will encrypt the message. So now perform the encryption. So the same process we will do. Here you have given this value P equal to 11, Q equal to 5, N equal to 55, 5 of N equal to 14, E equal to 7, D equal to 23. Now put this formula. Now put this value in the formula. So now 7, our message is 7. So 7 is to 7 mod 5, 55. 7 is the encryption key. Now you calculate. Now you do the calculation. You will get the 28 mod 55. So you will get the C equal to 28. Now we will perform the decryption. So decryption, our formula for decryption is C M equal to C is to D mod N. So our D is 23 and N is 55. So now put this value in the equation. So our ciphertext is 28. So 28 raised to 23 mod 55. Now we will do the calculation of 28 raised to 23. You will get the 7. So our message is 7. So now you will get the original value is 7. So this is all about the RSA algorithm. I hope you clear this idea. Thank you.